So we have put in data for the calculator. There are two ways that you will be presented data for this for bivariate. You'll either be given a list of data points in which you put them in L1 and L2, and you have to create the graphs, or, and this is what happens most commonly, is that they give you computer output and they give you the graphs, and then they ask you to comment on them. There are 3 graphs in which we'll be creating once we get to the assumptions part, but let's start with the hypotheses. So the problem said, is there sufficient evidence to suggest a linear relationship between treadmill time and ski time? So my null hypothesis is always beta equals 0. That would mean that there's no linear relationship. And the alternative is beta does not equal 0. And if it doesn't specify a direction, then you're just going to assume that it could be positive or negative, either one.
What is beta? Beta is the point
and where beta is the true slope of the population regression line between X and Y. So between treadmill time and ski time. So those are my hypotheses, and the only thing that changes is your X and Y every time. So you'll just insert whatever X and Y are in context. It's not too bad. So the assumptions, the first thing you're going to do, I'm going to draw like a little sidebar right here, because we're going to be making 3 graphs. We're going to make the scatter plot. We're going to make the residual plot. And then we're going to make we can either make a box plot or a normal probability plot. Which one do you guys want to do?
Normal probability plot.
Okay.
Oh, yes. Box plot would be
I like box plot. So with your calculator, I want you to draw all 3 of these. So the first thing is your scatter plot. Okay, so if I want to do a scatter plot, I go to second y equals. Stop talking. Enter. The type is the first one. L1, L2, zoom 9. Looks negative. So my x, whenever I draw this, I don't need any numbers, but I do need to label my x and y axis. So what is my x axis?
treadmill time.
Treadmill time. And my y-axis is ski time. They will be picky about labeling the axes. So this is my scatter plot.
Did you title the graph?
No. Now, the second thing that I want to do, if you got an error, then you need to go back and check your y equals and make sure that you don't have anything in your y equals. Like there should be no functions here. Sometimes they get left in people's backpacks and there's like random gibberish in here and it causes you not to be able to graph. Now, if I want to make the residual plot, the only way that you have residuals in your calculator is when you run a test. So there's 2 options of tests that we could run. Let's go ahead and do stat test and then linreg t-test. It'll take me a little while to get down there. Right here. Okay. G. Whoa. No. No.
Just go up.
It's,
go to the top.
I know.
No, don't go back up. Go back down.
There.
Oh, it's not linear. No, you missed
There.
it.
Okay. Now I want to hit enter. List 1, list 2, not equal to. You could go ahead and write all this information down because you're going to need it here in a minute. or you could just leave it be and go back to it later. Sometimes I just like to get all of my assumptions done first. After you've run the test, now my residuals are in the calculator. So I'm going to go back to second, y equals, enter, and my residual plot, I'll keep my x list L1, but I'm going to change. Okay, so you go back after you've run the test, you're going to go back and you're going to change the y list to L resid.
Yes, sir.
So you go to,
Yes, sir.
I think,
It's second
list,
list.
second stat, and you go down to resid. It could be 7, it could be 8 for you. Oh, why does that always?
Doesn't even have any extra.
If there's nothing there, that means you didn't run the test. So it has to run the test on L1 and L2 first for it to show up. Now you go back to Zoom 9. And here are your residuals. Now, when you graph this, your y will be your residuals. Your x is still treadmill time. So label your axes as residuals and treadmill time.
So glad it is not linear. If it were, then we'd have to do all that weird Y law data pattern.
Okay, the last thing I want to do now is make a normal probability plot of the residuals. So I'm going to go back to second, y equals,
1.
enter, and my type is now the last one, this guy right here.
Zoom 9. What are we graphing?
Change my data list to be residual. Did everyone hear me?
Probability.
Yes.
How do I get to residual?
Whoa.
List 8.
I do second stat 7, but whichever way you can find it. Zoom 9. This is my normal probability plot of the residuals. So my y-axis right here is z-score. My x-axis is residuals.
The x-axis is the trim. So we can pick which one we want to do. Correct?
You can do a box plot of residuals as well.
So you have to do all 3 of those?
Yes. So when you're given data, you will make all 3 of these graphs. I'm going to tell you, you will not be given the data very often, but I'm just showing you how to do it. So once you have all 3 of those things, we're going to start with our assumptions. So you have your 3 graphs that we made, the scatter plot, and it looked like this. I'm just rehanding it. I have no idea. And then we had the residual. So it looked something scattered. And then we had the normal probability plot of residuals, which looked like this. Okay, so you've got your 3 graphs. They should all be labeled like we did earlier.
The last one's Z, right?
Yes. You got your z-score. So my assumption number 1 is there is a random sample. So there is a random sample of, and how many data points do we have?
11.
11. And
Good one.
11 what? People?
Time.
But we're surveying people, so we'll just put people here. So the first one is easy to remember. The second one is you're wanting to say that a linear model is appropriate. So a linear model is appropriate. Nope, that's not how you spell it. Because of 2 things. Scatter plot linear and residual
Has no pattern.
plot has no pattern.
Remember when I got a question wrong, so I thought there was a pattern?
I think that was supposed to.
You still salty. I'm just a little disappointed.
Okay,
Kind of subjective
third one.
to an extent. It is, yeah, really. This whole class is subjective.
The third one that you say is the standard deviation of the y's are the same for all x values, so treadmill times, because scatter plot is evenly spread.
Huh? How do we know that?
Evenly spread across the x value. So if you look at the x's, there isn't like a huge gap between your x values.
Is this gonna be our test right up there?
Yes. And then lastly, the distribution is approximately normal, because this is where the normal probability plot comes in, because normal probability plot is linear. Or if you wanted to do a box plot, remember, you could say box plot is what?
Static.
No, box plot is approximately symmetrical. Has no outliers. I say that because it might show up on a multiple choice, something like that. Okay, so let's kind of go back. We've got a random sample. It's 1. Linear model is appropriate because scatter plot is linear. Residual plot has no pattern. The standard deviation of the y's are the same for all x's, and then you put that in context, because scatter plot is evenly spread. Then we have normal distribution because normal probability plot is linear. So that's why you have to draw all 3 of the graphs. And like I said, if it's computer output, then the graphs will be given to you and life is good and the Lord has blessed you. So sometimes these are given to you, but you still have to comment on them just like so. Now I'm going to go to calculations. So calculations, it's a linear regression t-test. So we did stat test F. So if this were computer output, you would actually have to do the calculations by hand because you don't have all of the data. So remember that the formula is T equals B over SB. So in which case it would be negative 2.3335 over 2.1. Wait, is that right?
That is great.
No, it's not. It doesn't give you that. The calculator doesn't give you SB, it just gives you standard deviation of the errors. So it gives you your test statistic, negative 3.95.
Outrageous.
Then it gives you my p-value, which is 0.00337. My degrees of freedom is 9. And alpha we'll assume is 0.05. Yes.
My word.
From there, my conclusion would be, since the p-value is less than alpha, I reject HO. There is sufficient evidence to suggest that there is a linear relationship between treadmill and sleep time. So this would be an example where it would be given computer output and it wants you to do a full write-up. If this were an AP test or even my test, the graphs would be given to you, but just kind of treat it like the graphs are there. They're not, but just imagine that they're there and they're all great. And the scatter plot's linear, normal probability plot is linear, and the residual doesn't have a pattern. This is like the perfect world. So the things that you would want to add on, or that would look a little bit different on your write-up, is if you were doing a confidence interval. So I think, at the bottom, right, wants you to do a confidence interval write-up. Remember that the formula is B plus or minus T star SB. And then if you're doing a hypothesis test, T equals B over SB. And from there, you'll have to get your test statistic, and then you'll have to do your p-value by taking TCDF of your test statistic, and then to infinity and degrees of freedom. If it's a not equal to test, what do you do to that p-value? You multiply it by 2. In this case, the p-value is given to you, but remember, sometimes this stuff is not there. So when you're doing a write-up with computer output, it's going to be a little bit more work on the calculations part, but less work on the assumptions part. So any questions? Yes.
What assumptions do we need on computer output?
The assumptions are the same for computer output and for...
We write them all to the graph.
Yeah, there will be a graph given to you, most likely. On part C, so how do confidence interval and inference test support each other? What magic number am I looking for inside the confidence interval?
0.
0. So if 0 is contained, then what does that mean? I did what? I failed to reject. And if it's not contained, I do not fail to reject, I reject. So we're looking for the magic number 0.